This lesson is nonlinear systems of equations. Our learning target is I can solve systems of equations. So in Math 1, you spent some time dealing with systems, which are just more than one equation. And then when we say nonlinear, we mean not a straight line. So a curve, a quadratic, a circle, a square root function, anything that's not completely straight. And that's what we're doing. And remember, the whole point of solving a system is to find where it intersects. So that idea is still going on. Alright, so here are important things to remember. So a nonlinear system of equations is a system in which at least one equation is not linear. So maybe one of them will be linear, but at least one of them is not going to be a straight line. Okay, and then here's some other things to remember. When you're talking about systems of equations, there can be one solution, so it would intersect only once. Multiple solutions, it would intersect multiple times. Or no real solutions, so it wouldn't intersect at all. Or infinitely many, which means that the system is like on top of each other. They're the exact same curve. So they're always touching, they're always intersecting, so they have infinitely many solutions. Okay, so we're going to do it really easy first. We're going to solve systems graphically, so you should be familiar with this. All we're going to do is we're going to use our Desmos calculator. I promise it is easier than the actual TI-84 calculator. Go ahead and put this in Desmos and then try to find the intersection. So pause the video and try it in 1, 2, 3. Okay, so here's what it looks like in Desmos. Notice that one of them is not a straight line. And then we're just finding where it intersects. So this one happens to intersect twice, meaning that it has two solutions. And remember that you will be writing the points like this, so make sure you're writing both points, not just the x one. Alright, so those are your solutions. Alright, let's try a couple more. Okay, so if you were using a TI-84 calculator, you would not be able to enter this into your y equals until y was by itself. So you would have had to subtract x squared over, and then you would have had to take the square root, and then you would have to remember that anytime you take the square root is a plus and minus. So this is why I keep telling you about Desmos, because it's so much easier. All you have to do is type this in Desmos exactly like you see it. You don't have to do anything to it, and then find the intersections. So try it in 1, 2, 3. Alright, so this first one is a circle, and you'll learn about those next year with me in Math 3. And then the next one is a hyperbola, which you'll learn about in pre-cal. And it has two solutions because it intersects twice. So it intersects at 3, 4, and it also intersects at 3, negative 4. So there are your two solutions. Alright, go ahead and solve this one graphically. If you're using Desmos, type it in. If you're using a TI-84 calculator, you got to get the y by itself before you can put it in y equals. Try this in 1, 2, 3. Okay, so the first one is a parabola, and the next one was a straight line. And notice that they don't touch at all. So this one, we would say no real solutions, because there is no intersection. Remember, if they were directly on top of each other, the exact same curve, that's when it would be infinitely many. Alright, and try this one again. Use Desmos. 1, 2, 3. Alright, so the first one is a square root function. We talked about that this year. The second one is a straight line. And this one only has one answer because it only intersects once. So my answer is 3, 7. Alright. So that's pretty easy. But now let's look at solving systems algebraically. Because if you do take further math courses, graphing is a great way to check your answer, but that's not going to be what the instructor is looking for. They're going to want you to solve it graphically. Okay, so I think the easiest thing to do with this one is to solve using substitution. So this one says y equals x squared plus x minus 2, and the next one says y equals 1 minus x. So if y are equal to each other, then these other two are also equal to each other. So what I'm going to do is I'm just going to get rid of the y's, and I'm going to substitute in the other parts of the equation. Okay, so I don't know if you automatically recognize that you have a quadratic, but the more you practice this, the more you'll pick up on what you have. And you always want quadratics to equal 0. So the first thing I'm going to do is I'm going to move this x to the other side. So x squared plus x is 2x. Still not equal to 0. I got to get rid of this 1, and I can only get rid of it by subtracting. Alright, so now we have a quadratic is equal to 0. We can solve this quadratic by graphing. We can solve it by factoring. We can solve it by the quadratic formula. It's really up to you and whatever method you're most comfortable with. I'm going to solve it by factoring just because it's a little bit faster. So I'm looking for two numbers that multiply to give me -3, but add to give me 2. And those numbers are 3 and -1. So my factors are x plus 3 and x minus 1. Remember that both of these equal 0 because that's what the equation says. So I'm going to set both of these factors equal to 0, and I'm going to solve them. So I get rid of plus 3 by subtracting, x equals -3, and I get rid of minus 1 by adding, x equals 1. Okay, so keep in mind that those are just my x coordinates, and like we did to the previous ones, notice we had an xy coordinate each time. So now we need to use these and plug them back in. Okay, so what I'm going to do is I'm going to clean this up. I'm going to pause the video really quick. Okay, so I'm going to start with this one first. And because the second equation is a lot shorter, I'm going to use the second equation. So if I know that x is actually -3, I can just replace that x with the -3. So y equals 1 minus a -3. Remember that becomes a plus, so it's 4. So my first answer is going to be -3, 4. And I'm going to do the exact same thing, but with the other one. I'm going to replace this x with a +1. And 1 minus 1 is 0. So my second answer is 1, 0. So just don't forget that whenever you find the x, you still have to plug it back in to find the y coordinate because you always have an x and a y coordinate as your answer. Okay, this one pretty much the same thing. So see how the y's are equal, so that means the other parts are equal. The y's are equal, so these have to be equal. So I'm going to set the parts in orange equal to each other. And once again, I have a quadratic. I always want quadratics to equal 0. So I'm just going to start moving stuff over. Now I'm going to subtract 3x. Notice that I'm placing them only under like terms because that's how math works. Alright, so here we go. So we have a quadratic equal to 0. Remember, you can solve quadratics by graphing. You can solve them by factoring. You can solve them by the quadratic formula. You can do whatever method you want. I'm going to choose factoring just because it's easier for me. So two numbers that multiply give me 1, but add to give me 2, or 1 and 1. So my two factors are x plus 1 and x plus 1. These factors equal 0. I'm only going to do one of them because they're the same factor. So I get x equals -1. So remember, I'm not done because I need to know what the y coordinate is also. So what I'm going to do, I'm going to take this -1 and I'm going to plug it back into one of the equations. I'm going to choose the top equation, and everywhere I see an x, I'm just going to write a -1. So I have y equals, remember I'm substituting in a -1, so I'm going to put it in parentheses like this. It kind of helps you keep it organized. So a -1 squared is a +1. A +3 times a -1 is a -3. And now I'm just going to do this. So 1 minus 3 minus 5 is going to be -7. So my answer is going to end up being -1, -7. And you can always use Desmos to check behind yourself and make sure we're getting the correct answers. Okay, now this one's a little bit trickier. So I want you to look at it, and I want you to pause the video, and I want you to think about what you might do with this one. So try this, pause it in 1, 2, 3. Okay, so here's what I would do. I'm going to take the second equation, and I'm going to solve it for one of the variables. I'm just going to pick one. I'm going to solve it for x, so I'm going to get x by itself. So I got to get rid of the 2y by subtracting. So 3x equals negative 2y. And I'm going to get rid of the 3 by dividing. So x equals negative 2/3 y. Okay, so now I'm going to take my answer. And if I know that x equals negative 2/3 y, then I can replace the x with that value I just got. So I am going to replace that x with negative 2/3 y. And then I'm just going to do the rest of the equation like I normally would. So it gets a little tricky because remember, you have to square the negative 2/3 and the y. So negative 2/3 squared is 4/9. You can use your calculator if you don't believe me. And y squared is y squared. Okay. I'm going to need a little bit more room, so here we go. Alright. Remember, this is like 4/9 plus 1 because you're just adding the coefficients. So that is 13/9 y squared equals 52. And I'm going to get y by itself. So I'm going to divide by 13 over 9. Or you can multiply by 9 over 13. And I get y squared equals 36. And the way I get rid of a square is to square root both sides. So y equals, remember, anytime you take a square root, you have a positive and a negative answer. So I have two y variables. Y is a positive 6 and y is a negative 6. I don't have the x coordinate, so now I'm going to have to plug these back in. So I'm going to pause the video and clean this up just a minute. So really, I'm just going to start with this one. And I can plug them into either one that I want to. I think it's a little easier to plug it into the second equation, so that's what I'm going to do. So I'm going to replace this y with the number 6. So I have 3x plus 2 times 6. 3x plus 2 times 6 is 12. Sorry about that. Equals 0. I'm going to get rid of the 12. So 3x equals negative 12. And I'm going to get rid of the 3 by dividing. So x equals negative 4. So one of my answers is negative 4, comma 6. And I'm going to pretty much do the same thing. I'm going to replace y with a negative 6 this time. Changes it just a little. Not bad though. So 2 times a negative 6 is a negative 12. So now I would add 12 to both sides. 3x equals 12. Now I would divide by 3 on both sides, so x equals 4. So my other answer would end up being 4, comma, negative 6. And once again, remember that we have two answers because we would have two intersection points. I think the hardest thing is deciding what to do first, and that just comes with practice. So I want you to notice that it says y squared equals 2x plus 13. And in the second equation, I have a y squared. So what I'm going to do is I'm going to replace that y squared with 2x plus 13. So here's what it's going to look like. X squared plus 2x plus 13 plus 6x minus 1 equals 0. Okay, so that allows me to solve for just one variable. So I'm going to get my like terms together. So I can solve it by graphing, by factoring, by quadratic formula. I think quadratic formula is easier for this one, but you can do whatever you feel like. So I need two numbers that multiply to give me 12, add to give me 8. Those numbers are 6 and 2. So I got x plus 6, x plus 2. These equal 0. I'm going to set them equal to 0, and I'm going to solve for x. So I get negative 6, and I get negative 2. Alright, so remember the last thing I'm going to do is plug these back in. You can go ahead and pause the video and try it. Just try plugging them back in. And it doesn't matter if you plug it into the first or the second one, it's whichever you prefer. So pause the video and see if we get the same answer. 1, 2, 3. Okay, so that might have been a little scary because when you take the square root, remember you get a plus and minus answer. That's how I'm getting this plus and minus 1. So I'm actually going to have 4 answers. My answers are -6, 1, -6, -1, -2, 3, and -2, -3. And remember, you can always graph those in Desmos and check. This graph is a little crazy. It's going to intersect 4 different times. Okay, this one's pretty easy. Notice that the y's are by themselves, so go ahead and use substitution and try this one all the way through. Pause the video and then I'll start explaining it if you need help. Try it in 1, 2, 3. So the first thing I did was I substituted where the y's were with everything in the x's, and now I'm going to get everything to one side. This one is not able to be factored. It's also not able to be graphed, so we're going to have to use the quadratic formula. Okay, so this one, we use the quadratic formula. Once we simplify, we notice this is imaginary. So this answer is just going to be no real solutions. Now, if any part of that did not make sense, you are more than welcome to go back and watch videos on simplifying radicals or watch videos on the quadratic formula. But we're going to move on. There's one more to try. Alright, so I want you to look at this and I want you to think about what you would do because this is the most difficult one that we've done. Okay, so I think what I would do is I would solve the second equation for x squared so that I can plug it in right here. So I'm going to move this y squared over. So I get x squared is equal to 21 plus y squared. So now I can take this and I can plug it in right here. Like this. Okay, so go ahead and pause the video and simplify it. And go ahead and keep going. See if you can get y by itself. Alright, so I got that y equals positive and -2. So I'm now going to take those values and I'm going to plug it back in to either the first or the second equation. I'm going to do the second one because it looks a little easier. You plug them back in and see what you get. Alright, so that's what I got. When I substitute the -2, I get the same thing in, so that's why it's only written once. And there's actually going to be 4 answers. And if you were to graph it in Desmos and check it, you'll see that it intersects 4 different times. So this is a little more challenging than what you did in Math 1, because you're in Math 2, so it should be a little bit. But it's pretty much the same, you're just looking for where it intersects. And now you know how to do it algebraically, and you know how to do it graphically. So go ahead and try your assignment. Let me know if you have any questions. I'm always happy to help. Bye.